Today we're going to look at substitution and equivalence. To evaluate an expression or substitute values means to replace each variable with a designated number to obtain a final value. So it means that every variable that we have will be given an actual number that's attached to it. So for example here, we'll say A equals 3 and B equals 4. So that means that any time we see an A, that's the same as putting in a 3 or having a 3 there. Every time we see a B, it's the same as having a 4 there. So we need to evaluate this expression here. This expression, 7a plus 2b plus 5. So we need to substitute in a equals 3. So a here, we'll substitute in 3 for that. B here, we'll substitute in a 4 for that. So 7a plus 2b plus 5. Here, it's 7 times a, remember? And this is 2 times b. So that means if we substitute in a, 3 for a here, that will make that 7 times 3. And this will be plus 2 times 4 because we're substituting in 4 for b here. Plus 5. Now there's no other variables that we need to substitute in, so that's what we're doing. So 7 times 3, we can evaluate this now. There are no more variables. It's just a normal mathematical expression. So 7 times 3 is 21. 2 times 4 is 8 and 5 is 5. So 21 plus 8 plus 5, 34. So if we evaluate this expression with these variables, 3 and 4, placed in there, we get the answer 34. If two expressions are equivalent, if they have equal values for any number substituted into the variables. So an equivalent expressions are going to get the exact same answer if you substitute in the same number for the same variables each time. So we've got a couple of examples. So substitute x equals 3 and y equals 6 into the expression 7 minus xy plus x squared plus 2y to evaluate it. So if we write down the expression here, 7 minus xy plus x squared plus 2y here, we're substituting in 3 for x and 6 for y. So every time we see an x, we put a 3. Now these are going to have a multiplier by next to them or in between them, and so are these. So every time we see a y, we put our 6. Every time we see an x, 3, and our y, we put a 6. So this is the same as now, we've substituted the values in, 7 minus 3 times 6 plus 3 squared plus 2 times 6. And we can evaluate this now, easy as pie. So we just need to use our order of operations. We need to do the orders first, so we can do that as 9. And that's not affected by all these other ones, so we can do these as well. So the multiply here, a couple of multipliers, 3 times 6, 18, 2 times 6 is 12. So we're left with 7 minus 18 plus 9 plus 12. And the answer to that is 10. Our second question here, x minus 3 and 3 minus x equivalent? You might see that and just say, of course not. Or you might say, yeah, maybe they are. They look pretty similar. They've both got a 3 and an x in them. Let's see. If we substitute in x equals 3 into both of these expressions. So x equals 3, that would be for the x minus 3. That would be 3 minus 3, that's 0. That's fair enough. And for 3 minus x, the answer is 0 as well, because that's 3 minus 3 as well. Both 0. So it appears that they might be equivalent. However, they both have to get the same answer, the same value for any value of x. So for any number that we substitute in for x, they have to get the same value for them to be equivalent. So let's try another one. Let's try 5. So x minus 3, that's 5 minus 3, that's 2. 3 minus x, that's going to be 3 minus 5, that's negative 2. So that's not the same answer, that's not the same response. They can't be equivalent, so not valid for every value substituted. Therefore, x minus 3 and 3 minus x are not equivalent. So you only have to find one value for which they don't get the same answer, and you know automatically they're not equivalent. And we'll be looking at different other methods for working out, determining whether two equations are equivalent later on.